Hello and welcome to the first video on my channel, Makita Repairs. Today I have two broken Makita Chargers. One is here, one is sitting next to me, which I want to investigate together with you and try to repair. Okay, off to the first charger. I will plug it into the power socket and see what the defect is. Okay, it's turning on normal like it's supposed to be. The green light is blinking, which means we have AC power and it is in standby. I have a 3 amp hours battery here with not fully charged. It's 3 out of 4. Let's see if the power supply, the charger is working. Okay. This might be our error. So the power supply is starting to charge and then aborting the charge. Now it's doing nothing. So it seems like we have some kind of power issue. Let's see if this one is cable related. As soon as we plug in the battery, the power seems to turn off. Let's try it again. Nothing. Let's rig it a little. No, nothing. Let's test again. No power taken. Okay, I just found one thing I'm gonna quickly show you. Seems like our problem might come from here, that we have a bad connector. So let's disassemble the charger and then measure the resistance of the cable and see if we can find the bad contact. So first of all, we have to remove these 4 rubber feet. I can easily remove them actually by hand. And underneath here we have 4 Phillips screws. And let's take the top off. Let's give the PCB a real quick inspection and see if we found anything obviously broken. So this is our main AC circuit with the rectifiers which are making high voltage DC current. Let's have a look if the fuse are fine. I put the multimeter in continuous mode, should beep, and let's measure the fuse. The fuse is fine, that's a good sign. Next off we have a varistor on these. It's this component. This is supposed not to be shortened. No short here. So let's measure the resistance of our power cable and see if we have an issue there. So what I'm gonna do, I'm gonna go with one probe on this side and the other one, I will put it into resistance mode so that it's not annoying us all. Oh, the cable seems to be fine. Either way, if we fix the power supply, we have to change this because we cannot let this as it is. So let's investigate further. So we know our fuse is fine. It's showing 0 ohms, 0.33. If I put my probes together, I'm ending up with almost the same. We know the harvester don't have a short. This is like over voltage protection. So where do we go afterwards? Afterwards we go through the rectifier, and then we go into this capacitor. So let's see if this capacitor seems to be any kind of bloated or leaking. And maybe let's go and investigate if we have the capacity it's supposed to be. Therefore I have to unscrew this so that I can get on the other side of the PCB. Move this part out of the way. How many screws I'm missing? Some screws that I'm missing. Yeah, there's one more screw I'm missing. Right there, you can see it. And there we have it. And now here we have our PCB. So these are the probes between the capacitor. Let's check the resistance. It's supposed to be 150 microfarad capacitor. So let's go to the capacitor test setup and let's check. This will not be the best result because we are measuring in between inside the circuit, so we have everything connected. So we're measuring 130 microfarad, which is not bad. So I would say capacitor seems to be fine. On these chargers we have like 2 charging circuits. I will zoom a little out to show you. We have like the main charging circuit, which is making the main power for charging the battery later, and we have this little help circuit, which is providing the 5 volts and that stuff for all the microcontrollers on the other side of the PCB to operate. So when charging or while idling, only this power supply is active, and while charging, also this power supply is active, charging the battery. Since the battery charger seems to work without any load, it seems to be this one okay. But let's investigate a little more. I will go back to continuity mode and then we check for some shorts. Let's see. This big MOSFET here is supposed to generate the power of the DC-DC converter. Let's see what we measure between gate and source. No short. Same for the drain and the source. And let's go between the other 2 pins. So it seems like our MOSFET don't have a short. These are used to shorten out sometimes. So let's see if we have any loose components inside the board. I'll zoom it in. take my tweezers. So on this side, everything so far seems to be okay. So let's go on the back side of our PCB, and first let's investigate our AC circuit on the back side, if we have any loose solder joints here. Which doesn't seem to be... Oh! Are you seeing this? So that's why it's very important to check the solder points. Let me switch to the microscope and let me show you what I just found. So we have this component here, and you're seeing this solder joint. Let me try if I can get it more sharp for you. Yeah. This solder joint here is loose. So probably this is causing our problem. So what I will do, I will put the soldering iron on and resolder this pin, and then let's see if this solves our problem. I'll turn on the smoke sucker, turn on the soldering iron, and I will come in with some new solder with flux included. Since this is a very, very big connection, it will take some time to suck the solder. Add some more. Remove the heat. This is looking very good. So let's see. Yeah, now the pin is not wiggling anymore. Let's see if we have any other loose pins inside this circuit. This all seems to be fine. Okay. Seems like we are fine now. It very often is happening on the big Makita Chargers with so the pin which was loose was from this tall component. So if they are on a lot of vibration, they're rattling a lot, and I already saw a lot of times that these solder connections are getting loose over time. Sometimes also from these MOSFETs, so all components which are on these big heat sinks and under a lot of leverage, they are sometimes breaking the pads down there on the solder connection. So with that said, let's put it back together. I will switch back to the big camera, zoom out for you, and put everything back together. Then we give it a try. And we have to figure out how this one is going. Whoop, like this. We have to come back anyway to replace the cable later on. So putting back on the fan assembly, we put in the 3 screws. That's these screws. Important, the spring is very important to be here. This is going in here. These cables have to be arranged going down on this side. Let me see if I'm getting it right. So let's put the cover back on. For now I So we'll let the screws outside, put the cable back into the power. So we didn't make it worse. This seems to be working. Let's see. Here I have my battery. Still on 3, on 4. So let's put it inside and see if we have the same behavior. This is looking promising. Okay, I will put this aside. For now I will let the screws open and didn't put it back together, and let's see if the battery is charging. If so, we can replace the cable and finish this one up. Let's see our battery charger and see what kind of problem we have here. So I will plug in the power. Okay, normal behavior so far. Let's put inside a battery and see what's happening. Beep beep. I can hear the fan. I don't know if you can hear the fan. I can take you nearby. Maybe you can hear the fan now. But I don't have a charging light. So now the question is the charger working? And do we just have a broken LED? I think the easiest way to figure this out. Let's disassemble this. If I'm taking the battery out, the green light is back up blinking. So if the battery is charging, the red light is supposed to be turned on. Maybe it's defective, that's why it's not on. Let's see. Let's unplug the power. By the way, this charger has a way better cable. So this is fine in this case. Same procedure as on the other one. Let's turn this baby back around. Let's see how we are looking on the inside. And I think I found our problem. I will put on the microscope and then I'm gonna show you what I just saw. So let's go a little up and then let me try to get the focus. So we have our yellow light, we have the green light, and the red light seems to be missing its head. Let's see, is the head stuck in here? No, it doesn't seem like that. So first of all, let's try to find the missing part of the component. There it is. Just fall down to the ground. So here we have it. So our LED seems to be broken. So this is quite an easy fix. We have to replace the LED. While we're inside here, let's have a quick look to all the other components. If we found anything which is not looking good. So far, just seems to be the LED broken. And since we need to be on the underside of the charger, you can see on the inside it's a different revision of PCB board. See here it's differently screwed to the main body. It has one screw in the middle here. Let's go and disconnect this one. And it's held by more, not only by this one screw. Let's go to the underside of the PCB and see if we have anything else like the loose torn pads. So let me give this a quick search if we found anything. Yeah, it really just seems to be our LED which has a problem. So let's see. The LED is here on the board. So let's see on the back side. The LEDs are supposed to be somewhere in this area. So the LEDs are supposed to be in somewhere in this area. They're hard to identify. 1, 2, 3 LEDs, and we don't have a lot of other components. We have some of the optocouplers here. So let's try to find these. This seems to be our optocouplers, and then we have one LED here, one LED here, and one LED here. And our broken one is this one. So let's try to desolder this and then replace it. So in order to resolder it, I will use a solder sucker and soldering iron, and I will add a little bit of leaded flux, and I will turn on the fume extractor. So seems like our component is loose. Let's go to the other side. And it just fell right out. So arm number 1 and arm number 2. Put these aside, and now I will try to find an LED to replace it. So I found the missing component, the LED. Luckily I had one, and I have to say these PCBs are very well. They did a very good printing job on these. So they have the orientation of the diode, and they're including the orientation or picture, how it's looking on the inside, as you can see. So we are supposed to insert this LED like this, which I will do right now. Then I need the soldering iron, and I have to turn the PCB upside down. I will try to. So this is our component we want to solder. I will zoom in a little for you. As you can see here, I will really quick secure one side with this crocodile clamp. Came in with the soldering iron, came in with some solder. Soldering iron is hot. Wait until it's solidified. Turn on the fume extractor. And let's solder the other side. Those solder got stuck. Now cut both ends away. Put them aside. We don't want to have these inside of the PCB and later causing a short. Fume extractor can be turned off. So let's put everything together and let's see if we now have a fully functioning charger again. So that's this part. Remember, this part was only secured with one screw, which goes in right there. So we put the charging port back into place. this cable. Now it's time for the upper housing. Okay, I will give it a quick test. If it's working, we can put it completely back together. So I will put it into the power with the green light. That's good. Let's put in the battery, and we're getting the red light. So let's just assemble it. Plug it back in. Give it a final check. Fan is spinning up, LEDs is on. This one is fully repaired. Back to charger number 1. As you guys can see, the battery is charged, so the charger is back operating. So the only thing we have to do, replace the faulty cable. I will show you in a second. And then this one is fully fixed too. Take it out of the power. So guys, I found another cable of another broken device, or not broken device. You can buy these on Amazon. So let's change the cable so that we don't have a hazard here anymore, and then we have 2 fully repaired chargers. First of all, take out the PCB. Put this aside. Take out the PCB. And let's come back here with our soldering iron. That's the soldering iron at 400 degrees. I'll zoom in a little for you. That was the first one. And while it's hot, let's come here with the solder sucker again to make the hole nice and open. And the second one. Give it a gentle pull with the tweezers. Suck the rest of the residue. Get rid of the outer isolation. And get them to the back copper. And we have to insert them into our PCB. Make sure that you're getting every part of them inside and that they're not touching anything else. I will secure this here with a clamp. And let's solder these bad boys in. Wait for the soldering iron to be hot. And see how the solder is dropping into the hole. Same for the other side. There it goes. Give it a nice and gentle cut. And that's it. Let's resample this boy and see if we really fully fixed it. So we have the upper housing part inside. Now it's 4 screws. And for everybody who's interested in, I was buying these 2 chargers as a bundle for 22 euros, including shipping. So 11 euros per charger. And I think the price to buy these ones new is around 30 euros. And let's put it into the power supply. And we have the light, put in the battery, it's charging. So guys, this is how we get two Makita chargers. Be aware the faults can differ on other chargers. These were two very untypical faults I already saw. If you like this kind of videos and want to see how I will repair in the future other components, mainly brushless devices from Makita, hit the like button and give the channel a subscribe. Thank you for watching. Have a great day.